Happy Friday, everyone. Welcome to today's season premiere of Learn Robotics Live. My name is Liz from Learn Robotics, and this is a course on a variety of special topics ranging throughout all subjects in robotics. So I'm super glad to have you on board today. Whether you're tuning in during your lunch hour or you're abroad and it's way past your bedtime, thank you so much for taking time out of your busy day to watch this episode. Today's episode is going to be all about building a prototype with Arduino. We're going to be making a RGB LED come to life. It's going to be a blast. You don't need any experience to get started, but what I do recommend is that if you want to maximize your learning on these live streams, grab the materials and build this project along with me. Around this video, if you're watching on the Learn Robotics website or if you're watching on YouTube, you can click in the description box below or on the button above and sign up for the free course where you'll gain access to the code examples, the wiring diagrams, and the replay of this video so that you can go ahead and build these prototypes and actually gain these skills. So what I wanted to do is I wanted to kind of introduce you to my setup. So this is what I call the Brady Bunch frame here. I've got a bunch of different camera angles to show you. I wanted to share with you my desktop. So I've got the Arduino IDE already installed. I've got the wiring diagram for our project. And then of course, I've got the actual workspace. So you can see me wire this up and you can build this project along with me. All right, so before we dive into the computer, I think it's important that I tell you what materials you're going to need for today's project. So to start off, you're going to need a breadboard. And if you've never used one of these before, this is what we're going to be connecting the wires and the LED to. You're going to need my favorite controller, the Arduino Uno. And I recommend getting one that isn't a clone so that you have less drivers to install. You're going to need 3 220 ohm resistors or greater. You're going to need 4 jumper cables. Ideally, you'll take a blue one, a red one, and a green one, as well as a black one. Also, I recommend getting a pair of snips. That'll just clean up the circuit, make it look a lot nicer. And then finally, you're going to need a USB cable so that we can get the software onto the Arduino. And then, of course, you're going to need a computer. So you cannot do this project using a tablet. It's very difficult to program the Arduino using a tablet. So I highly recommend you can get a Mac, you can get a Windows, you can use Linux, but you will need an actual computer. It could be a laptop or a desktop. And for those of you that are curious, this is the trusty mid-2012 MacBook Pro. We've got it going strong here. This is what I'm going to be using to program today. All right, so now that we've got our setup, we've got all of the materials, what I want to do is show you the wiring diagram, and then we're going to build the circuit out. All right, so what we've got here is we've got the wiring diagram, as you can see over here. We've got my setup here, and what we're going to do is we're just going to use the wiring diagram to connect the RGB LED to our breadboard. So the first step that I like to do is I just like to get this LED situated. So you may, depending on how yours comes in the packaging, you may have to just kind of move the pins so that you can place them onto the breadboard. And the way the breadboard works is you've got all these different letters on one side and you've got the numbers going across. So you can kind of see that here. So basically, all of the same numbers are the same connection, and all of the different letters are different connections. So basically, if we're looking at letters being a row and numbers being a column, everything in the same column is connected. Everything in a different row is a different connection. So these two pins left to right are going to be different, but if you're down like this column here, you're going to be connected. And you've also got 2 different sides of the breadboard. So you've got this side is independent of this side and they're separated by a channel. And this is just so that if you have an integrated chip, you can plug it over here without shorting the pins out. And so the last thing you need to know is you've got a couple of power rails here. So the plus is just typically what you'll wire in your positive battery power to, and then your minus would be your negative battery power. We're not going to really use that today, but I just wanted to point that out. So what we're going to do is we're just going to take a look at this LED. So most LEDs have a polarity. This one's a common cathode configuration, which means we're going to be plugging this longer leg. You can see it. You can plug that longer leg into the ground, and then we've got, going from left to right, we have R, ground, G, B, and then we'll be controlling the colors based on each of those legs. Alright, so I'm just going to go ahead and plug these into 3 different numbered columns, and we'll just try to put it towards the center just to make this easy. And so when you're done, it should look kind of like that. So once we have it plugged in, we're going to want to add in our resistors. So the resistors need to go between here and another number. So we're going to use basically the red pin, so the R pin, the G pin, and the B pin. They all need to have resistors on them, and that's just because we want to limit the amount of current that this LED is getting so that we don't burn it out. So typically you won't see resistors placed like this. They're sitting way too high, so that's why I've got the snips. And so typically what we're going to want to do is cut the resistors down so that they sit flush against the breadboard. So for example, we will just bring that one over and see how it sits nice and flush against the breadboard, and that's great because we don't want it sticking up. So we'll go ahead and we'll take our snips and we'll just cut these just a little bit. So just like that. And we'll run the next one, and that's going to be our G wire. That looks good, and you just want to make sure that they're seated as close to the board as possible, so you can kind of see those are connected. And then lastly, we will take our snips and cut here and here, and just kind of peel them down, and we'll go off of the G pin. And you want to make sure that they're all on separate pins. You don't want them to be plugged into the same column because then they'll share the same signal and they will short out. So we don't want to do that. And just take your time, and it can be a little bit challenging to place them in there, but just be patient with it. And then you just want it to sit flat against the board. So something like that should be pretty good. And so what we did is we fed out the signals from each of these pins over to these other columns, and we're going to go off of these columns directly into the Arduino. So we'll start with our red jumper wire. Red is this one right here, so we will follow it over, and then we'll plug that one, will be plugged into the Arduino. We'll do green. That one is, we skip a pin because we've got to do our ground wire, so we're going to go off of the 3rd pin from the left, and that's this guy, so that's over here. And then we've got our last wire, which is blue, and you can kind of see I'm like tracing it. So you just follow it to the resistor, to the other end of the resistor, and then over. And anywhere along that column will be the right connection. So now that we've got our wires, we can go ahead and add in our ground cable. So that's going to be the 2nd one from the left. Anywhere along that column should be good. And then we'll plug that into the Arduino as well. All right. And if you want to snip the pins on the LED so that they sit closer to the board, you can do that as well. I'm just letting mine sit above the board, which if you're doing something that's going to be more permanent, I highly recommend just trimming them. Keep the ground pin a little bit longer just so that you know the orientation. All right, so now what we can do is plug the wires in. So we're going to start with the red one, and we're going to start at pin 9 on the Arduino. And then we're going to go RG, so we'll do green on pin 10, and then B will be on pin 11, and then the black one is going to go into ground. So you'll find the ground terminal on the bottom. There'll be 2 pins that say G and D, and you'll just plug the black wire into there. And that's pretty much it. So that's our configuration for wiring up this board for our prototype. And so the purpose of today is really to just explore RGB and RGB patterns by using an RGB color picker and then mapping the red value, the green value, and the blue value to the different pins. And then what we should get is the color of the LED will be representative of the inputs that we give it. So now that we have everything wired up, it's time to head on over to the software, and you are going to need Arduino set up. And if you've never used Arduino before, this is a good time for you to check out the Learn Robotics website. If you search 4 steps, it'll bring you, the first guide will be 4 steps to write any Arduino program. So if you've never written anything in Arduino, this guide is literally the 4 things you need to know about writing an Arduino program and actually creating something that works. All right, so let's head on over to the computer, and you can see I've got the diagram up as well. We don't really need that anymore. So what I am going to do is I'm just going to make this screen a little bit bigger, and we can go ahead in. And this is just a brand new sketch. You can create one for yourself. I've named it RGB Live because we are live today, episode 1. So thank you guys for tuning in. Be sure if you have any questions to go ahead and stop me. Let me know in the comments, in the chat. Let me know what you're thinking. If this is the replay, go ahead and reach out to me. Find me on social media if you have a question, and I'm happy to help. These classes are for you guys. I want to make sure that all of your questions are answered and that you're having a lot of fun with this. So the first thing I like to do with my Arduino programs is I'll give them comments. I tend to teach people to over-comment at the beginning, especially if you don't really know what's going on. The comments are just like English. They're not going to be read by the controller, but it's just a good way for you to put a little mental note into the code so that in a few weeks, if you come back to this code, you know what it does and you can reference things easily. So this is just going to drive the color of an RGB LED, and we have it in the common cathode configuration, and that just means that the longer pin is connected to the ground. And I'm just going to put today's date and my name, and that's about it. So you'll notice that Arduino populates these 2 methods automatically. These are required. You have to have them in your code in order for it to compile. We have a setup, which is like an initialization routine, and we have a loop, which is similar to a main method or a main routine that gets executed on the board. And this runs from top to bottom sequentially, and then when it gets to the bottom, it goes back to the top, and it runs through the code again. And it'll just keep going through the code until you either run out of battery, you unplug the Arduino, or the Arduino gets broken, or whatever may happen. So for us, what we want to do first is we want to map our pins that are plugged in to the signal lines on the Arduino. We want to map them to our software. So what we're going to do is we're going to create some variables. And if you're familiar with coding, you may want to use the pound define. You may want to create globals. It really doesn't matter to me which method you want to do. It's just personal preference. And if you're more involved in software, you may make decisions based on one or another. But at this point in time, it doesn't really matter to me what you decide to use. I'm just going to set them up as integers. You can use a constant int, or you can just use an integer. for a simple program like this where we're just doing some prototyping and just some demonstration, I'm just going to keep it as simple as possible, just to get you guys onboarded and honestly just to kind of get things working, and then we can always go back and clean up the code and optimize it later. So the first pin I want to put in is the red pin. So I'm just going to call it red pin, and that's on pin 9. You can use really any of the PWM pins. It just all of the pins on the LED that are receiving a signal have to be on a PWM pin. So you can use 3, 5, 6, 9, 10, 11 on the Arduino. So anything that has the little tilde, you'll see on the actual controller. Anything that has the little tilde next to the number, those are PWM, and you'll see like Arduino has it listed on here. So as long as it says that, you're free to use it. I'm going to use the PWM pins on the way they're set up here. I'm going to use pins 9, 10, and 11. Feel free to use whichever ones you want. Just know that you're going to have to change your code to match whichever wiring that you decide to use. So we'll go ahead and we'll do that for all of them. So we got to do a green pin and a blue pin, and that's all we have. So the setup, so LEDs are going to be taking information from the controller and sending it to the environment. So this is going to be considered an output. And if you're confused about inputs and outputs, you can learn more about them in the 4 steps to any Arduino program blog article, or you can check out my Arduino for Beginners course that'll go more in depth on the different types of sensors and how you classify them. But for now, just know that the LED is an output because we're taking data from the controller and sending it to the environment. So we're going to use a method that's built into Arduino to set this. It's called pin mode. And we're going to do that on the red pin, and that's going to be an output. And this is the syntax for the method pin mode. If you go on the Arduino documentation, you can search pin mode, and it'll tell you all about how this method actually works. So I'm just doing this for all of the pins that we have. And we've got a blue pin. And that's about it. So one of the interesting things about this project and why I wanted to do something like this activity rather than just showing you how to blink an LED or turn an LED on and then off is that you've got some color that is going to be added to the LED when you change different values. So if you've ever worked in like Photoshop, or if you've ever worked in PowerPoint, or if you've ever used any tool that has a fill button, you'll notice that colors are represented on the screen using an RGB or a hex value. And so with this project, we're going to be using the RGB color value to set the color of our LED. And I think that that's a pretty cool project because you're going to actually get a bunch of different variations of the LED, and you can blink the LED, you can randomize the color, you can do a lot of different things to explore how this works in an application that's a little bit more exciting than just turning an LED on and off. So that's kind of the main story behind this project. But I hope you guys are having fun so far. Remember to use the chat if you have any questions. I'm on answering questions right now, so if you have something, feel free to send me a message, and I'm going to answer them for you as soon as they come through. If you're building this, be sure to put a, "Hey, I'm building this" in the chat. Let me know that you're working on this project because I'm trying to gauge interest in who's actually watching this just for fun and who's actually following along to actually build up the projects. All right, so back to our code. So typically what I like to do is I like to create methods that contain a separate function, but because we're just testing, let's go ahead and write this inside of the loop, and then we'll go ahead and we'll create a method later so that we can optimize how this actually works. So in order to send color values to the LED, we're going to have to use a range of numbers. And so when you find an LED, when you find a hex code rather, you're going to be given 3 different numbers. There's going to be a red number, a green number, and a blue number. And that's true for all hex colors that you use, whether it's in Paint or whether it's in Photoshop. You're going to choose a color based on either a color picker, and then that color picker will calculate or assign it a hex value. So what you can do is you can open up an RGB color picker. They have one free on Google. If you just type in RGB color picker, you'll be greeted with one that's right on the main screen. And if you go into the bottom left corner, you'll notice that we've got 3 different values. The first one's the red value, the second one's the green value, and the third one's the blue value. And so kind of a nice thing about this is you can play around with the slider wheel and you can get a color. What I will say is the closer you are to red, green, or blue directly, the better the color is going to look on the LED, and that's just based on resolution. It's based on how we interpret colors. But for the most part, the purpose of this activity is to just kind of get you familiar with color mapping and then taking these colors and then actually writing the computer code for it and then sending it over to the Arduino. So for a simple example, let's actually send over each of the colors. We're going to send over red, then we're going to send over blue, and then we're going to send over green. And so to do that, we're going to use a command called analog write. And that's just because we've got our pins plugged into the PWM pins on the digital side of the board, and that allows us to use an analog write, which will allow us to send an 8-bit signal, which just so happens to be in the exact same range of 0 to 255. So the first thing we need to do is choose our pin. So the red pin, we're going to set it to 255, and we'll just say that 255 is the max, meaning it's going to be red if you set it to 255, and if you set it to 0, it's going to be not red. It's going to be basically negated. So, all right, and we'll do analog write. We're going to do the green pin, and that's going to be 0 because we want to test the red value. And analog write, blue pin. And that also will be 0. All right. So let's go ahead and compile that. You can just go and click the little check mark on the top left of the screen. And then the next step is to, let's go ahead and switch over. I'm going to show you how to get this thing set up. So you're going to take your USB cable and you're just going to plug it into the Arduino. You'll see that it turns on. And then what you're going to do is, mine's already got some code on it, so it's lighting up. Then what you'll do is you're going to go back onto your computer, and you're going to go up to Tools, and you're going to make sure your board that's selected is the Arduino Uno. And then your Tools is going to be port, whatever port the Arduino shows up on. For Macs, it'll say something along the lines of USB modem. For Windows, it'll say something along the lines of COM4. It may even call out that the Arduino is actually connected there. So make sure you click that. And then you can go ahead and click Upload. And if all goes well, you'll see that everything's good. And once I did that, I just wanted to do a little close-up for you guys. You'll see that now the LED is in fact red. So let's go ahead and do another example. What I want to do is change this over to, let's make it green. So we'll just change this to a 0, this to 255. And then what I want to do is I want to show you the top view, what I'm working on. And now I'm going to hit the upload button, and you should see that it's going to turn over to green. And so if all goes well, if you're following along, hopefully you're having this success as well. If not, please leave a comment below or inside of the chat so that I can help you out. All right, I'm going to just go back into the software and I'm just changing the value of that analog write on the blue pin to 255, and then I set the green one to 0. So we'll go ahead and we're going to upload that, and we should see that come through, and now it should be blue. That's pretty cool, guys. All right, so hopefully you guys are having fun with this. So the next part of this project is to actually play around with different mixtures of RGB to get various colors. So if I wanted to go from blue, let's say, to purple, we would bump up the red value because red and blue makes purple, and we'd keep the green value at 0. So we'll go ahead and we'll do that. So now we should get a nice little purple color. That's pretty good. Yeah, it looks pretty good. And what you can do now is you can play around with different values on your analog writes for the red, the green, and the blue pin. And if you need to reference an RGB color picker, go ahead and open the tool from Google, play around with the slider, and test a bunch of different variations. If you have any questions, feel free to add them in the chat. If you're wondering something, or if you have an idea, or whatever it may be, go ahead and add them to the chat. I'm happy to have a conversation with you about it. But hopefully you're having a lot of fun with this. If you wanted to kind of make it flash, what you can do is you can keep the color on, and then you can shut it off. And so to do that, you just set it all to low. You just set all the pins to low. You can initialize them as low as well. But what I want to do now is I want to spend some time cleaning this up to make it quicker for you to actually generate these colors. So previously I talked a little bit about writing methods, and a method is basically a function that can be reused and then called with different input values. So you can use input parameters to basically alternate the code for a variety of different functionalities that do basically the same thing. So for example, instead of me having to write these 3 lines of code multiple times to get 3 different colors, I can just write 1 line of code by calling the method. So let's take a look at that now. So I'm going to call this method set RGB, and the return type is just going to be void. If you're not familiar with return types or what this void means, it basically means that we're not calculating anything. We're not going to be returning some sort of answer that we are going to use later. It's just going to be the return type will just be void, and we'll just use it as such. The name of the method is the second thing. So you can call this whatever you want. I'm just calling it set RGB because that's what we're doing. We're going to be setting the RGB color. And then the input parameters are what we're going to be telling it. So we want to be telling it 3 different numbers. We want to tell it a red value, a green value, and a blue value. So we're going to create some input parameters so that we can do that. So I'm just going to call it RGB. And you need to have the variable types as integers because we want to be able to send it numbers. So this is just the skeleton of the code that you're going to need to create this method. And what we're going to do is inside of this method, we're going to put the 3 lines of analog write. Just cut those out, and then what we'll do is we're going to paste them inside of the body of this set RGB method. And so what we want to do is instead of hard coding in these values, we're going to replace them with the variables. So let me not cut that. I'm just going to paste in an R. So then we got G, and we got B. So essentially what will happen is we're going to tell it what the R value is. So let's say we tell it we want it to be 255. This code will actually substitute the 255 into the body of the method. And that will allow us to create a ton of different combinations of code literally just by calling this method. So to call the method, what we're going to do is, let me just move this over just a little bit. What we're going to do is copy this right here, and we're going to just paste it inside of loop. And so what we want to do is it's the name, and then we're going to provide it 3 input parameters. So let's just set it to be red. So that's going to make the R value 255, the green value is going to be 0, and the blue value is going to be 0. And we always end inside of the method each line with a semicolon. So what we could do is just leave a comment. This should set the color to red. And let's go ahead and just compile that, make sure we didn't type anything incorrectly, and then we'll go ahead and upload it. And then what I want to do is do a little switch over and show you guys that it is in fact red. So now, instead of writing and changing those 3 lines of code, all we need to do is change the 3 parameters of our set RGB method. So let's go ahead and take a look at this again. So now what we can do is let's just say we do a quick 1-second delay, and 1,000 milliseconds is equal to 1 second. So that's why I put 1,000, because the delay method requires it to be in milliseconds. And so then what we can do is we can set the RGB again, and let's just say we want it to be green. So it's the first value is red, the second value is green, the last value is blue. And we can do a delay. So what this will end up doing is it's going to set it to red for 1 second, and then it's going to set it to green for 1 second, and then it's going to go red, green, red, green. So we'll go ahead and we will send that over. So we've got one little typo. Just make sure when you're doing commas you use 2 slashes instead of 1. It's always good to do a quick compile. Typically the error messages will pop up on the screen. So let me just recreate that so you guys can see what the issue was. So I went to compile it and it threw an error. And so what happened was I put in a comment, and in order to do a comment you need 2 of these. So to fix that, you'll just do 2 forward slashes and then hit compile again. It should compile no problem, and then we can go ahead and take a look. Go ahead, send that over. So we're expecting it to be red for a second, green for a second, red for a second, green for a second. Let me show you guys how that's going. And so that's kind of fun to play around with. So what I would like you to do is to just take some time to go through and work on changing some of the values in the set RGB method. You can create your own values. You can do patterns. Really the possibilities are endless with this. I just wanted to give you guys an overview of how the RGB LED works, how you can play around with color pickers and use that to generate different colors for your project. And really just have kind of an actual tangible project that you can work on using this technology and using the LED functionality. So one thing I didn't cover that I think is important for me to say is how do we actually turn the LED on and off, and how do we get it to be the standard LED white? And so those are 2 things that I want to address right now. So the first one will be to shut it off, so no color. And we're going to go back over to the computer and we're going to make a quick little modification in our loop method. And what we'll do is we can do one of 2 things. We can do a digital write to all of the pins and shut them off, or we can do a set RGB to 0, or to 255 would be fully on, 0 would be off. And we can do that for 1 second. And what I'm going to do is I'm just going to comment this whole block of code out. And to do that, you can just select it all and then hit the command or control key, I believe, on Windows, and then hit the / button. And that'll comment all of them out. So this should turn it off. To turn it back on, we can do a set RGB to 255 on all of them, and then we'll do another delay. So what we're expecting it to be is just a standard white colored LED, on, off for 1 second. So let's go ahead and just verify that we don't have any typos. And that looks good. So now what we can do is head on over, and now I'm going to push the code over from the IDE over to the Arduino, and you can see we've got a nice white color LED that's doing some blinking. It may look a little bit blue, and that's probably just because you're catching some reflections. So there we go. And so that's how you turn the LED on and off. You can use the digital write command. You're just going to have to do a digital write pin, like red pin, and set that to low. But since we have this set RGB method already made, we can set it to 0 to make it off. We can set it to 255 to turn it on, and then everything in between, and a mixture of that is going to be a color. And I did want to point out that there is something interesting about this project. If you do set up the colors and you use a color picker, what you're getting is a percentage, like a proportional percentage of the color, like the higher you set it. So the closer to 255 is the closer you're at 100% brightness. So if you set it to 127, you're going to be at 50% brightness. And so it's going to make the color less bright. So it's going to be a duller version of that color. But that combined with other colors gives you kind of that variance in shades. So it's not going to be perfect. If you take your RGB color picker color and you just plop it right into the Arduino code and it doesn't look the same, it's probably because you're getting a percentage of brightness and you're not necessarily going to get that much of a differentiation with one single LED. So I did want to point that out. If you do want to play around with it, you can. You can go ahead and add more LEDs. You can make this more complicated. You can randomize colors. Those are a couple awesome ideas for next steps with this project. So that's all I have for today's lesson. I hope you guys had a lot of fun with it. If you guys like these live streams, be sure to give this video some love. Hit the thumbs up button. Let me know in chat. Find me on social media. Tell me how awesome this is, because I want this to be about you guys. If you have a specific topic you want to learn, please let me know. I'm going to be doing these every Friday at 12:30 p.m. Eastern Standard Time, live from Learn Robotics Studio. It's going to be a lot of fun, so join me. Click the button above this video if you're on learnrobotics.org. Sign up for the free course and get yourself the replay of this video. Get yourself access to the code example. So all the code that I just wrote will be available inside of the course. You'll also have access to a list of materials and everything you need going forward. And if you're on YouTube, you can find that information in the description box below, as well as all of the materials that I used inside of this course. So thank you so much for joining me. If you love this, again, smash that thumbs up button. Show this some love. If you have a friend that would love to see this, share it with them. I can't wait for next week. This has been a lot of fun. So thank you guys so much. And yeah, I will see you guys in the next one. It's so weird to say that live. Like, who even says that live? I'll see you in the next one. Stay tuned, I got something funny to show you. One of the cool things about doing these videos is you just get to see my face. What are you guys still doing here? Go up there, go check out the course, sign up for free, watch this replay. If you missed something or if you need a refresher, it's 100% free. Go to learnrobotics.org, find yourself inside that course, check it out, download the code, try out the projects, ask me questions. It's a lot of fun. I've got over 100 different robotics articles on the blog, so come find me. It's going to be fun. So yeah. Guess what? I'll see you guys next week. It's Friday. You can hang out with me again. All right, guys. See ya.